Okay. So now let's go on to the second question over here. It says simplify the square root of 48 minus 3 square root of 27 plus 5 square root of 32. And if you recall what we said on Friday, when we started talking about radicals, we said that the only time you can combine, or that, which means add or subtract radicals, is if the radical part is identical. It's like adding and subtracting of like terms. You have to have, when you're adding like terms, you make sure that the letter parts are identical, and then you add the numbers in front. So the same thing over here. We can only add these or subtract them if what's inside the radical is identical. Well, if I look at it like this, I can't combine anything because none of these are like radicals. But another thing that we learned how to do is to simplify radicals, to make them as simple as we can by breaking them up into two parts. Let's say we have the square root of 48. We're going to try and break up 48 into two numbers that when they multiply together, they're going to give me the 48, but one of them is going to be a perfect square. And if we look at the numbers like 48, I'm going to write it over here. We have a number like 48, we could break it up into 24 and 2. But neither of these, that's not a good choice because neither 24 nor 2 is a perfect square. Then we could do 16 times 3, because 3 into 48 is 16. And that is a good choice because 16 is a perfect square. So we're going to rewrite the square root of 48 as the square root of 16 times the square root of 3. And then since the square root of this is a perfect square, we know what the square root of 16 is. That's just plain 4. So we've simplified the square root of 48 into 4 times square root of 3. If you don't believe that they're exactly the same value, you can just do it on your calculator. On your calculator, press your square root button, put in 48, you'll get an answer. It'll be an answer with a long decimal. It'll fill up the whole calculator. If your calculator has set 10 positions, it'll fill up all 10 positions. If you have a calculator that has 100 positions, it'll fill up all 100 positions. It is a non-ending, non-repeating decimal. It's what we call an irrational number. But if you did 4 times the square root of 3 on your calculator, you would get the exact same irrational numbers. These are irrational numbers. 4 times the square root of 3 is the simplified version of the square root of 48. Well, now let's go to this next number. It's minus 3 radical 27. So looking at the radical 27, let's just deal with that first. I know I can break that up into 9 and 3 because square root of 9 is a perfect square. And we know that the square root of 3 is just 3. In other words, the square root of 27 is 3 times the square root of 3. But now we have to remember there was an additional minus 3 in front of it. So I have to take this minus 3 from before and multiply it by the 3. Since this 3 and this 3 are both outside the radical, we can multiply them together. Negative 3 times 3 is minus 9, and we bring down our radical 3. And now we look at our last term, 5 radical 32. And going to the square root of 32, I think you might realize right away that you can do 16 times 2. Again, we just talked about 16 being perfect square. So this will become 4 times square root of 2. But don't forget, we had this 5 in front of it before, and the 5 and the 4 both being outside can be multiplied. So we get 20 square root of 2. Okay, we've actually done all the hard work now. Now we go back, everything is simplified. Now let's check if we have any like radicals. And I see 4 radical 3 minus 9 radical 3. The numbers inside the radicals are identical, so I just combine the 4 and the negative 9, which gives me negative 5 radical 3. I can't combine it with the 20 radical 2 because over here, there's a radical 2 in here, and this is a radical 3. You cannot, these are not like radicals. This is as far as you can go. This is your answer. Your answer would have been negative 5 radical 3 plus 20 radical 2. Okay. Let's just talk about, since we've talked about adding and subtracting of radicals, let's talk about multiplying radicals. And then, of course, after we talk about multiplying, we'll talk about dividing. And then we'll be able to work with radicals in any way. Again, we're concentrating on square roots. We talked about the other day how the radical sign, this can be used for other roots as well. For example, if you had something like this, where there would be a little 4 in the check mark, that's called the index, that would be saying that's not the square root of 5. This is saying the 4th root of 5. It's asking you what number 4 times is going to give you 5. We're going to be concentrating basically on square roots, but every so often I may mention something that has to do with a higher index. Okay, let's say asks you to multiply 3 times radical 5 with 2 times radical 10. I want to multiply these 2 radical expressions. So the rule is very simple. Any numbers that are outside the radicals can be multiplied together. Any numbers that are inside the radicals can be multiplied together. Let me mention, they both would have to be square roots. You couldn't have a square root, the cube root. It's always 2 square roots, 2 cube roots, whatever. They're both, the indexes have to be the same, but these are not the indexes. These are the coefficients. These are the numbers outside. These are both plain square roots. We take the numbers outside, multiply them together. 3 times 2 is 6. Then we take the numbers that are inside the radicals. 5 times 10 is 50. So whereas when you're adding and subtracting, the numbers inside the radicals have to be the same in both radicals. When it comes to multiplying, you can't multiply a number outside a radical with a number that's inside, but any number outside the radicals can be multiplied together, and the numbers that are inside the radicals can be multiplied together as well. Of course, once you get an answer, you want to see, can you simplify your answer? And we think about 50, and I know that 50 could be broken up into 25 and 2. And I picked specifically 25 and 2 because 25 is a perfect square. The square root of 25 is 5. And now I can take the 6 that's outside and multiply by the 5, which is now outside. And my answer in simplest form is going to be 30 times the square root of 2. Now, what if I had something like this? Radical 3, so this was question 1, here's question 2. We have the square root of 3, parentheses, 2 radical 6, minus 5 radical 12. What if we wanted to simplify or multiply this? Now, if you think about it, first of all, looking inside the parentheses, these are 2 different radicals. This is a 6 and it's inside the radical. This is a 12. Remembering our rule for combining radicals, we can't combine them. They're not like radicals. So what we really have here is a single term, the square root of 3, times a binomial. This is 2 terms. But we've done things like that before. When you have a single term times a polynomial, you have to use the distributive property and multiply each term inside the parentheses by what's on the outside. And that's exactly what we're going to do, remembering that it's understood that in front of this square root of 3, it really is an understood 1 there. Even though we didn't write 1 square root of 3, it's understood as if there's a 1 there. So when we go to multiply, we're going to take the 1 and multiply by the 2, which will give us 2. And we'll multiply the 3 times the 6, and we'll get the square root of 18 for our first term. Then we're going to go back and take the 1 and multiply by the -5, which will give us -5. And then we'll do the 3 times this 12, and that'll give us radical 36. So now we've done the multiplication. Now we're going to try and simplify as much as we possibly can. Notice we do the simplification at the end because once we multiply, we might get things that can be made into smaller. And the square root of 18, we certainly can simplify into the square root of 9 and the square root of 2. And the square root of 9 is going to become 3. So I'll take the 2 that was originally outside and multiply it by this 3 that's now on the outside, because when we do the square root of 9, we no longer have it inside a radical, and we're getting 6 radical 2 as this first term simplified. Going to the next term, we have the square root of 36. But the square root of 36, we know, is already a rational number. Square root of 36 is just 6. It doesn't have a, if we can simplify it by just getting its square root, we do. So now we can take this 5 that's on the outside and multiply by the 6, and we get -30. Now these cannot be combined any further. These are not like radicals. This has a square root of 2. There's no square root of 2 attached to this. So this is as far as we can go. My answer becomes 6 square root of 2 minus 30. Just a couple of things to make, I think, life a little bit simpler. I'm going to show you some interesting things. what if I gave you the square root of 7 times the square root of 7? What would usually happen? Well, I just told you how to multiply. You take the numbers outside. Well, there are no numbers outside, so there's 1. So we don't have to do anything with that. And then we take the numbers inside, the 7 and the 7, and we multiply them together. And we get the square root of 49. But we know what the square root of 49 is. That's just 7. Let's try this with another number. What if I did the square root of 10 times the square root of 10? Well, the square root of 10 times the square root of 10 is the square root of 100, which is just 10. Are you beginning to see a pattern? I hope you are. It turns out anytime you have, and I'm going to use an A, because it's any number. A can be any number, as long, of course, they have to be positive, because otherwise it's not real, but we want to talk about real numbers. Anytime you take the square root of A times the square root of A, you're going to get the square root of A squared. And remember, when we're doing variables, we divide the exponent by the index, and then the square root, the index is 2. We'll just get A. So the basic rule is anytime you're multiplying a square root by itself, you get the number that's inside the square root without any radical sign. Square root of 2 times square root of 2 is plain 2. Square root of 100 times square root of 100 is just plain 100. I'm so sure of this that if I did the square root of 1,952 times the square root of 1,952, I know exactly what that answer is going to be. It's going to be 1,952. Because anytime you're multiplying a square root by itself, the two numbers inside the square roots are identical, then you really just removing the radical and you're getting the number without the radical. In other words, the square root of A times the square root of A is simply A as a general rule. Okay, that's going to help us when we're going to be doing examples that we're going to want to simplify. So let's say I gave you this example. I'm going to give you a multiple choice example to try. You want to simplify this, and the question is radical 5, parentheses 3 radical 10 minus 4 radical 5. That's your question. Here are your answers. I'm giving you this to try now, and while you're doing that, I'm going to be taking attendance. I hope everybody looked at their emails and saw I sent everybody an individual email as to what their status is now in this class. If it said that you're in danger of failing, you better pay attention to it and see why it says you're in danger of failing. And make sure you take care of any, it usually means that you're missing tests. Make sure you take care of anything that's missing. Olivia, Isis Barco. You here? Alvaro? Alvaro, you here? Great. Good morning. Lewis Hart? Emma?
I'm here. Good morning.
Good morning. Demetrius? Desmond? Shania? Shania here? God, I saw your name before. Caden? Kayla?
I'm here.
Hi, good morning. Sanjita?
I'm here, Professor.
Did you see I sent you a note?
Yes, I've seen it.
Okay, please. See if you can respond to me. Ariana?
Yes,
Ariana,
I'm here.
hi, good morning.
Good morning.
Tahira? Hi, good morning. Michaela? Kiana? I see you're here,
Good morning.
good morning.
You sent me the email, but it said that I didn't take the midterm, but I did.
Are you sure it's the midterm you? Let me look, I have my sheets right here. No, I have no record of you having taken the. Go check your thing again. Are you sure you pressed enter or whatever?
Yeah, it's on Delta Math.
When did you take this?
I took it on Monday.
No, it doesn't make sense. I just looked yesterday and I checked 3 times. And I have you having taken neither the midterm nor the pre-midterm.
The midterm was on Blackboard, right, Professor?
It was on Blackboard.
Yeah, I did complete it, but I don't know why. It says it didn't do it.
you check again and I'll check again. And
Okay,
I'll
let
be
me
in
check.
touch with you by email again. But I have never had a problem where they said that you didn't take it and somebody did take it. Check to see, maybe you didn't. It's on Blackboard. And it says on the thing, midterm. There's a section that says midterm, and that's what you have to go to. So 20 multiple choice questions. Sound familiar? I mean,
Did you receive mine, Professor?
I'm sorry.
Did you receive mine? This is Jenna. We're Jenna.
Yes, I certainly did. I sent you an email. What did my email say? It would have told you if you didn't take the midterm.
Oh, because I haven't checked my email yet. But
Oh,
I just
okay.
have, yeah. But I take the pre-midterm yesterday as well.
Okay, great.
I see it, Professor. What I was looking at before was on Delta Math.
I'm sorry.
I see it right now. Like, I'm on Blackboard. You're right. I didn't take it.
Okay, so can you take it with, I'm leaving it open. I left it open so that you can take it.
Yeah.
Okay, great. Carly. I see her here. Okay. Jenna, and we just talking. I know you're here. Tatiana. Good morning. Naya, I know you're here.
Morning.
Yeah, good morning. Kazandu.
I'm here, Professor. Morning.
Good morning. Trina Small. And Jean, I see you're here. Okay, let me answer I saw there was some questions on the chat. Let me answer that. Okay. The pre-test, the pre-midterm is not just for your practice. I said it a few times. It is considered as a quiz in the class. So far, there have been a total of 3 tests plus a midterm. 2 tests on Delta Math and the pre-midterm. Those are considered as class tests. When there's starting, I may as well tell you, after this period, there is going to be quiz number 3 posted on Delta Math. So we're going to be up to quiz number 3 on Delta Math. It's on chapter 5. It's on the fractions. Anybody who does, there will probably be at least 1 more quiz and possibly 2 more quizzes. If at the end of the term, aside from the midterm, and of course, aside from the final, there are a total of 5 or 6 quizzes and tests, I will take the best 4 marks, and that'll be your quiz average for the term. So if you didn't do 1 quiz, I'll just take the ones that you did do. But it's obviously to your benefit to do as many of them as possible because I'm going to take the best marks. So if you haven't, I've left everything open. Any quiz, any homework, anything can still be done. Just make sure. No, you will not lose any points. There is not, I'm not giving, I've decided I'm not going to consider anything late. On the quizzes, on the homeworks, I did put late if you didn't do it, but the homeworks, really, I only count to see if you did the homeworks. Even if you got a 10% on the homework, it's considered as you did that homework. So, and you have to do the homework. So the homeworks are, and I've been seeing there, a lot of people have been up and doing everything on time. Obviously, if you did things timely, or if you answered questions in class, remember, I've been giving extra credit. All that's going to help when it comes to your final grade. But right now, make sure you've got the bare bones minimum. You've got to have the quizzes done. You have to have the midterm done. I was surprised that there's so many people who did not do the midterm. I assume that maybe it's a little confusing if it's your first term using Blackboard, but there are, I'll say it again. There are 2 tests now posted on Blackboard. One was the pre-midterm, which was in the quizzes and tests section. And one was the midterm, which is, I always put in its own section. The midterm will always be in its own section. The final is in its own section so that it's easy to find it. But any other tests given on Blackboard are in the tests and quizzes section. And if you haven't done, check, it's your responsibility to check that everything is done. Again, it took me quite a bit of time to go through all the papers and all the work and make sure to send everybody an update as to where they are. But really, this is something that you can really self-check. You can check on Delta Math. You go to your account, it'll show you how much is done, how much is still available to be done. And the same thing on Blackboard. Just go to Blackboard and you'll see the tests and quizzes and the midterm. And if you go to Blackboard and you go to your grade, and you can just click on it. You can go to grade, it'll show you exactly what you've got as a grade on each of those tests. Again, if you're having any problem and you need the midterm, I think the midterm is still open. I'll make sure after class that it's open for the next couple of days. But really, if you don't see it and it's closed, it really was supposed to be closed last Monday. It was supposed to be finished by next Monday. But I will not give anybody any, you won't lose that points, but you must take it. And if you get a notice that you're failing the course, you'll know it's because you haven't done the work. Okay. All right, let's go to this problem and see if we can do it. Where did I put my? Okay, so what we want to do is we want to multiply. Let's do the work over here. This is not one on one. we want to do the square root of 5 times 3 radical 10. Notice sometimes I'll say radical 10 and sometimes I'll say the square root of 10. It means the same thing. Minus 4 radical 5. And we want to know if nobody sent me anything in the chat, but let's do it together now. Remember, this is as if there's a 1 in front of the radical 5. So we're doing 1 times 3, which will give me 3. And we're doing radical 5 times radical 10, which is giving me radical 50. And now we have to multiply the 1 radical 5 times the negative 4 radical 5. So again, the 1 times the negative 4 gives me negative 4. But here's where we're going to use our shortcut. Radical 5 times radical 5. Obviously, I could say square root of 25, but square root of 25 is just plain 5. So instead, I can just remember, anytime I'm multiplying a radical by itself, it just gives me the number without that radical sign. It's plain 5. So this will give me negative 4 times 5, which is negative 20. But I still want to look at this square root of 50. And I remember that I can break that up into 25 and 2. And the square root of 25 is 5. And the 3 times the 5 is 15. So what I end up is 15 radical 2 minus 20. I cannot combine them. This does not have a radical 2. Be very careful about only combining like radicals. I hope most of you got choice D. Okay, going on with this. What if we had something that looks like this? I want to multiply 3 radical 2 minus 4, that binomial, by 7 radical 2 plus 9. Now, I cannot combine either of these because these are not like radicals. Remember, think about those square roots as if they are x's. If this would have been 3x minus 4, and this 7x plus 9, you would have known exactly what to do. You want to multiply these two binomials. Well, exactly the way you did it with variables, that's exactly the way you're going to do it with radicals. These are two binomials, and we're going to use FOIL. Remember that? First, outer, inner, last, to multiply these two binomials. So doing that, we're going to do the 3 radical 2 times the 7 radical 2. That's our first. So we do the 3 times the 7, which will give us 21. And the radical 2 times the radical 2. Oh, that I know right away. That's just plain 2, because when you multiply radical by itself, it just gives you the number inside the radical without that square root sign. In other words, it's 21 times 2. The first term gives me 42. Okay. Outer. That's 3 radical 2 times 9. So I multiply the 3 times 9. The 9 is not inside a radical, so I multiply it with a number that's outside the radical. So that gives me 27 radical 2. Inner is the -4 times the 7 radical 2. -4 times 7 is -28 radical 2. Remember, there's no radical to multiply. You only multiply the numbers outside with each other. You multiply numbers inside with each other. And finally, the last is -4 times 9, which is just -36. And now we're going to combine like terms. So I have a 42 and a -36. Those can be combined because they are just plain numbers without any radicals. 42 minus 36 is 6. The 27 radical 2 minus the 28 radical 2 can also be combined. 27, since these are like radicals, they both have radical 2's. I do 27 minus 28 is -1 radical 2. Do not go any further with this. The 6 minus 1 cannot be combined because the 6 can, this is a -1 radical 2. It could only be combined with something that has a radical 2 next to it. It's like a 6 minus 1x. If you don't want to, you don't have to put in that 1, and you could just write it as 6 minus radical 2. Either of these answers are correct, and as simple as you can get. So basically, when you're multiplying a combination of radicals or binomials of radicals, you're going to do it just like you do binomials with regular variables. You're going to use FOIL, and you're going to simplify as much as you can. Okay, here's one for you to try. We'll see if you come up with the right answer. Anybody that comes up with the right answer, or anybody who comes up with an answer, put it on the chat so that you can get extra credit. Again, you get extra credit whether it's right or wrong. You get credit for doing it. Okay, so this one I want you to do. I want you to do 5 radical 3 minus 6 times 5 radical 3 plus 6. See if you can multiply. Those are, again, binomials with radicals, and you're going to have to use FOIL. I'm giving you a few minutes to try it on your own. Okay, I think we should try working on it together. Did anybody come up with an answer? Okay, Emma did. I'm going to give you extra credit. Let's see if her answer is correct. Okay, so I'm gonna sort of erase this so I have room to work. And we're doing, let's rewrite it. 5 radical 3 minus 6 times 5 radical 3 plus 6. And again, what we're going to do is we're going to do FOIL first. 5 radical 3 times 5 radical 3 will give us 25. And remember, the radical 3 times the radical 3, which will just give us 3. Outer will be 5 radical 3 times 6, which will be plus 30 radical 3. Inner will be negative 6 times 5 radical 3, which will be minus 30 radical 3. And finally, last will be negative 6 times 6, which will be minus 36. And let's see what we have here. 25 times 3, those are just numbers that have no radicals in it. That's just 75. The 30 radical 3 and the minus 30 radical 3, those are like radicals. But when we do 30 minus 30, we get 0. In other words, these cancel each other out. So all I'm left with is the 75 minus the 36, which is indeed 39. And you are 100% correct. How did you get? 39 is the correct answer.
Awesome.
Okay, let's try another one. Yes. And Jean, I'm going to give you credit for doing that also, even though I think you just pressed the wrong button. Before we do another one, let me just mention there is a shortcut we can do here. If we noticed, did you notice something interesting about these two binomials? The two binomials that we had looked almost identical. One was 5 radical 3 minus 6 and was 5 radical 3 plus 6. They were the only thing that was different between these two binomials is the sign in between them. Those are what are called conjugate binomials. When we multiply conjugate binomials, it turns out that the outer and the inner are going to turn out to be exactly the same, except one's going to be a positive and one's going to be a negative, just like we got over here. Positive 30 radical 3 and minus 30 radical 3. When you have two things that are look exactly alike, but one is positive, one is negative, and you're combining them, they're going to cancel each other out. So if you notice that ahead of time you have conjugate binomials, and it's very obvious, you just have to keep your eyes open, then you can make your life much simpler. Because then all you have to do is multiply the first terms together, and that'll give you the 25 and the 3, which is 75. And the last terms together, and that'll give you the negative 36. And you can combine them to the 39. You don't have to do the whole FOIL because the outer and the inner will cancel each other out. Why do extra work if you don't have to? But of course, you have to only can do it when you have conjugate binomials. Now I'm going to give you another pair of conjugate binomials. I'm gonna give you two questions to try now. Here's the first one. 6 minus radical 2 times 6 plus radical 2 is your first question. And your second question is going to be similar, but it's going to be 6 minus radical 2 with a square on the outside. I'm going to give you time to do both of these questions and see what you come up with. Again, if you answer on the chat, you'll get extra credit. Hey, Kiana, I'm going to give you extra credit for that one. Okay, and Kayla and Emma also came up with answers. Okay, so let's see if we can work with this. We have a few people have finished it, so obviously it's time we could do it. Notice this first pair is a conjugate pair. They are the identical binomials, except one has a plus and one has a minus. So therefore, we can just do first and last because we know the outer and the inner are going to cancel out. So we'll do 6 times 6, and that'll give me 36. And then we'll do, forget outer and inner, we don't have to do it. Square root of 2 times square root of 2, which is just going to give me 2. And a negative times a plus is going to give me negative. So it turns out I get 36 minus 2, which is 34, and I think that's what everybody answered. 34 is the correct answer. And I want you to notice something very interesting. It happened before, it's happening now. We had two binomials that looked very complicated. They were both had radicals with them. But because they were conjugate binomials, when we ended up multiplying, the answer didn't have any radical in it at all. And that's always going to happen. Anytime you multiply conjugate binomials, you end up with just a plain number without any square roots. Well, now let's look at the second one. This says 6 minus radical 2 with a square on the outside, which I'm going to rewrite as 6 minus radical 2 times 6 minus radical 2. I am multiplying the binomial 6 minus the square root of 2 by itself. So I have to write the exact binomial twice. Now, this is not conjugates because they're identical. They both have minuses. So in this case, I have to do the whole FOIL. First, 6 times 6 will give me 36. Now we do outer. 6 times negative radical 2, which gives me negative 6 radical 2. Inner will be negative radical 2 times 6. Remember, the 6 is on the outside, the radical 2 is that the 2 is in the inside, so I can't multiply them together. I just do minus 6 radical 2 as well. And finally, minus radical 2 times minus radical 2, minus times the minus is plus, and radical 2 times radical 2 is just plain 2 without any radical. And now we can combine our like terms. The like terms are this 36 plus the 2, which is 38. And the minus 6 radical 2 and the minus 6 radical 2, they do not cancel out because they both have the same sign. Minus 6 and minus 6 is minus 12 radical 2. And you cannot combine this 38 with the 12 because the 12 is attached to this radical 2. These are not like terms. These are not like radicals. This 38 is just a plain rational number. This is a 12 radical 2. You cannot take away that 12 from its radical 2. You can't separate them. Okay. Let's just talk for a few minutes about, we talked about adding, subtracting, and multiplying of radicals. Let's see how far we can get in terms of dividing radicals. Because once we do that, we really are going to be in a good place. Then we can talk about how to solve equations that have radicals in it. So let's talk about, what would be the case if I had, let's say, radical 24 divided by radical 15. Okay, what do we do when we're dividing two radicals? Well, just like adding and subtracting probably basically follow the same rules, multiplying and dividing pretty much follow the same rules. And remember, the rules were that you take the numbers that are outside, there happen to be no numbers outside, you can divide those by each other, and you can take the numbers inside and you can divide those by each other. Okay, now there was nothing outside, but we have a 24 and a 15. Now, if you think about it, 24 and 15 do have a common factor. They both have a common factor of 3. So I can divide both of the numbers inside the radical by the 3, which will give me a radical 8 on the top and a radical 5 on the bottom. In other words, just like I would do 24 over 15, in regular numbers, if they're inside radicals, as long as they're both inside the radicals, I can divide both of them. I'm basically dividing both of them by the square root of 3. So dividing this will give me the 8, and dividing this will give me the 5. And you would say, well, this is as far as we can go. That's it. Except there's a rule that is understood and accepted by all mathematical books, and it's just a standard acceptance that when the terms simplify, is used where you have fractions, you can't leave a radical in the denominator. You have to do something called rationalize the denominator. So this is something we didn't have to worry about when we were multiplying or dividing or adding and subtracting. But once we have fractions, if the term simplify is used, it includes in its meaning that if you have a fraction, that you don't leave a radical in the fraction. So the question is, if we take this, I'm going to take this simplified version, radical 8 over radical 5. To say rationalize the denominator means to end up with a rational number, a number without a square root in the denominator. And if you think about it, you can play around with your fractions as long as you always do or multiply the numerator and the denominator by the same thing. As long as you are taking your, whatever you're doing, multiplying your denominator by, you'll do the same thing to your numerator. You're not changing the value of your fraction. We talked about this last chapter when we were dealing with fractions and how we were renaming our fractions to make them have common denominators, etc. So we were always, whatever we did to the denominator, we did the same thing to the numerator. So guess what I'm going to do here? I'm going to think, if I would multiply the square root of 5 by the square root of 5, then I would just get the real number, the rational number 5, and I get the number 5 without any radical, because anytime you multiply a radical by itself, it just gives you the number inside the radical. And that would be a good thing, because then I wouldn't have the square root in the denominator. But if I'm multiplying the denominator by radical 5, I'm going to have to do the exact same thing to the numerator. Notice that will then give me square root of 40 over 5. So rationalizing the denominator means multiplying the denominator by something that will make it a rational number, that will make it a number without a radical. The only thing that's left to do here is to look, can I simplify this further? And you might recognize that the square root of 40 can be broken up into the square root of 4 and the square root of 10. Remember, we try and simplify our radicals. Now, this is just a regular radical. 40 can be broken up into 4 and 10, where the square root of 4 is just 2. So it turns out that this becomes, in simplest form, 2 radical 10 over 5. Now, don't make a mistake and try and divide this 5 into this 10. This 5 is no longer in a radical. It's not in a radical. Numbers outside radicals can only divide into numbers outside, numbers inside into inside. And that would be what would be considered the simplest form, because you only have a radical. If you're left with a radical, it's not in the denominator, it's in the numerator. Okay, let's try a couple of more. I'll do a few more with you, and then I'll give you a chance to try. Okay, let's say I gave you this 5 over radical 6. Again, I'm gonna do what we did before. I'm gonna see if I can simplify anything first, and I can't. The 5 is outside the radical, the 6 is inside the radical, and the 6 can't be simplified either, because the only thing I could break up 6 into would be 2 and 3. Neither of them is a perfect square. So it looks like it's in the simplest form that you could get it, except the big problem is this square root, this radical in the denominator. So therefore, we're going to have to rationalize the denominator, and we'll do that by multiplying the top and the bottom by the radical 6. Remember, I always decide what I'm going to do based on the denominator. And notice what we're left with. In the numerator, we have 5 radical 6. We can't multiply them because the 5 is outside the radical, the 6 is inside. And the denominator, we have radical 6 times radical 6, and that's our special case. You multiply a radical by itself, it just gives you your number, and this is your answer in simplest form. Don't tell me you think the original is simpler than the other one. It's not how it looks. It's by definition, no square root in the denominator. If it says simplest form, you can have a square root in the denominator. I think it's time for you to try one on your own. Suppose I gave you this fraction, the square root of 3/7. I'm going to start you off, and then I'm going to leave you to finish it up. Notice we have a whole fraction in a radical. What does that really mean? What that really means is that it's the square root of 3 over the square root of 7. So when you have a whole fraction in a radical, just separate it so you put a square root on the top and a square root on the bottom. Now, see what you could do to simplify this. I'm giving you a few minutes. Okay, let's see if we can do this. Obviously, I can't do anything with the 3 and the 7 like this. It looks like it's a simplest form, except again, we're dealing with that problem of having a square root, a radical in the denominator. So what I'm going to do is I'm going to multiply by the square root of 7, so that when I multiply the square root of 7 times the square root of 7, it'll give me 7. But of course, whatever I do to the top, I have to the bottom, I have to do to the top. So I'm going to multiply the numerator by the square root of 7 as well. And here I'm just going to multiply the 3 times the 7. That'll give me 21. So this will be the square root of 21 all over 7. Remember, it's not in the radical anymore because I multiplied it by itself. And the square root of 7 times the square root of 7 is just 7. I look at the square root of 21 and think, can I simplify it? And the answer is no, because the only thing 21 breaks up into is 3 and 7, neither of which is a perfect square. And I cannot divide this 21 by this 7 because the 21 is inside a radical, the 7 is not. So this is our answer in simplest form. The square root of 21 over 7. So let's just go through the steps again. If we have a radical, a fraction with radicals in it, first of all, we separate it so that the radical on top it's a radical on top and a radical on the bottom. Then we try and simplify the radicals as they stand. And after we've done that, look if there's any radical left in the denominator. If there is, then you've got to multiply it by itself to get rid of that radical. But whatever you multiply in the denominator, you're going to multiply the numerator as well. Now, I just want to show you one other interesting thing. And let me, as I said, I mentioned there's a quiz on chapter 5 posted on Delta Math. Make sure you do it. I am not going to be giving homework on Delta Math on chapter 6 yet. I'm going to wait until Wednesday to make sure that we review all these things that we've learned, because we've learned a lot of things before I start giving you homework in it. So let's say I gave you a question that looks like this. Three over 4 minus radical 3. It's a fraction that has radicals in it. But the problem, and I can't simplify anything, because first of all, I can't combine the 4 and the radical 3. This is outside, this is inside, they're not like radicals. I can't simplify it. But the problem is that when it says simplify, I have to, because there's a radical in that denominator. The square root of 3 is causing me problems. And the question is, what do I do? And if I found my rules from before, I would tell you, oh, multiply the top and the bottom by radical 3. But that won't work. Why? Because if I multiply the bottom by radical 3, which seems to be the proper thing to do, since this is a binomial, I'd have to use the distributive property. And in my denominator, I'd end up with 4 radical 3 and negative radical 3 times radical 3, which is just minus 3. And I'd still be left with a radical in the denominator. So multiplying by the radical 3 is the wrong thing to do. But I still have to rationalize this denominator. We have to get rid of that radical. So here's what you do. if your denominator is a binomial, it's not a single term. If it's a single term, if it wouldn't have had the plus or minus, I just use the square root of 3. But if it's a binomial, it's a plus or a minus in each one. What you're going to multiply by is the conjugate. Now, what is the conjugate? Of 4 minus square root of 3. Well, it's the exact same binomial except with the opposite sign. So it would be 4 plus square root of 3. And the reason we multiply by the conjugate is because I know when I'm multiplying conjugate, we just saw it before, so we spent some time doing it, that when you multiply conjugate binomials, you're left without any radicals. The inner and the outer cancel out, you're left with just regular numbers. So anytime I see that my denominator is a binomial with a radical, I multiply by the conjugate, which means I'm going to multiply by 4 plus radical 3. And I'm always going to do the bottom first. I like to do the bottom first because I want to see that my radicals actually disappear. Now remember, when I'm multiplying by the conjugates, I don't have to do the FOIL. I just do first 4 times 4, which is 16. And radical 3 times radical 3, which is just 3. And this becomes 60, the minus and the plus is minus, becomes 16 minus 3, which just becomes 13. Notice by multiplying 4 minus radical 3 times 4 plus radical 3, I am getting rid of the radical. I am rationalizing the denominator. Of course, I have to do the numerator as well. Now be careful here. This is a binomial times a monomial. I have to use the distributive property. I have to take 3 times 4 and get 12. And 3 times radical 3, which is just 3 radical 3. Don't forget that you have to multiply the 3 by the radical 3 as well. And here is your answer. Notice you have no radical in your denominator. You have rationalized your denominator. You can't simplify this anymore because you could only divide it if you had something that went into all the 4 numbers here, 12, 3, and 13. Nothing goes into all 3. There are 3 numbers there. You'd have to have something that goes into all 3 numbers. Okay, this is where we're going to start out next time with the reviewing, adding, subtracting, multiplying, and dividing of radicals so that we can start on solving radical equations. Anybody have any questions they want to ask?
Hi, I did my quiz and I just was wondering if you had got it. I did it on Thursday.
Which quiz? On Delta?
The quiz, I mean the test on the midterm on Blackboard.
Well, let me see what,
I was doing the quiz and then I had ran out of time because was doing something, but I did some of the quiz on Delta. I did both of the quizzes.
Shania, that's your Shania? Yeah, I see you've done everything.
Okay, thank you.
Thank you. Okay, have a good day then, everybody.
You too.
Bye-bye.
You too.